Welcome to the Group 81 demonstration. Next, I will go over the setup of MRC, CouchDB, and Ansibles. In MRC, we create three instances for the front-end CouchDB and Markdown Harvester. For each instance, they have their own key pair. We use this key pair to manage the instance via SSC. But first, we need to connect to the university VPN, and now I'm just like SSG, and now I connect to the Master Harvest instance. And then we need to define some security groups security groups for this instance, and each of which has its own special security group. For example, in order to manage the instance via SSH, we need to have the SSH security group check. And in order to manage the CouchDB database, we need to open the POC 5984. Once the instance is created, we need to allocate volumes to the instance and use mount to attach the file system to the specific location. And these volumes will be where we use to store our data. And this line, we use it to create the directory, and this is we use to format the volume. And here we mount the data, we mount the volumes, and here we precise the mounting. Now the instances are set up and ready to be used. When deploying Markdown Harvest, we try to start CouchDB service. At the same time, we can open poke address and add administrators through scripts. Then we start downloading the configurations needed for Markdown, such as Python 3 and PIP. Once the script is complete, we can start the servers by typing this line, like Ansible playbook covers the YAML. Okay, now the Python application is running, and we can go to the CouchDB, and now it's 109, and we can set a message in Markdown like and publish, and now we can check. Now it's 11110. So the message has been stored into the Markdown data. My demonstration is over.
Next, I'm going to demonstrate how we implement the front-end application. So for the front end, we use Grafana as our data visualization tool. We log into this endpoint, this website. You can see this is our homepage of the front end, which includes several data visualization statistical charts. And as you can see, the charts in the right bottom corner is still rendering because the Twitter data is super big and it's still querying and processing data. So for the rest, in the middle of the now it's rendered. So now in the middle of the homepage, we have the geo map, which demonstrates the sentiment distribution of tweets about tourism worldwide. You can just drag this world map to whichever place, whichever country you want. I can see there are data points on it represent the sentiment value. Yeah. So for the other charts, there are overnight tourism visitors in tourism regions around Australia. So this is for the cities, and this is for the states. On the right-hand side, we have the language of posts about tourism on Mastodon as well as from the Twitter data. Here's the data, the language distribution. So To implement this Grafana, first, of course, we need to run a Grafana service on a particular instance on the MRC. So what I've done is to start a Docker container which run the Grafana image. So to run this Grafana container, I use these following lines in the grafana start.sh. I use docker run -d to rename. We use the name parameter to rename the container so that it will not automatically generate some weird name. We use Grafana to identify the Grafana container. We open the port 3000 so that we can access the page through this 3000 port. And here we set the result to be always so that every time when the container is down, it will automatically restart. So here we set a GF panels disable standardized HTML equals to true parameter, environment parameter. We set this parameter to true because we want to embed the geomap, which is rendered by the full map box, which will be discussed later. Within our Grafana data visualization, so that's why we would like to use this environment parameter. And at the last line, we define the image we want to run, which is the latest version of Grafana. So by running this this shell script, we can run a Grafana as a Docker container. So here, if I log into that exact instance on MRC and I use sudo docker ps-a, you can see here is the container Grafana, and we open the port 3000 and the name is Grafana. So now we have the Grafana instance. Then we want to query some data. So first, I'm going to talk about how we implement the geomap. So as talked before, the geomap is created by the tool Mapbox. When log into the homepage, you see here you can create a map in the studio. If you click here, you can see there. You can create several styles. The style is just like the data visualization you want to define. So you can create a new style, and now I'm just going to show the style that I previously developed. And as you can see here, this is exact the same geomap we show in our Grafana data visualization. And to add these data points on this world map, you can just add a new layer and choose data visualization, and you can upload the data. So here we can use this specify data type, and here we want to use JSON type because on the Grafana on the CouchDB, here I gotta log in again. So on the CouchDB, we already filter all of those Twitter data which have the geo information. As you can see here in the BB box, we have the longitude, we have the latitude, but this is not the exact GeoJSON data type. So we want to use a Python script to use request package to transfer the original JSON type into the GeoJSON data. So it should look in this way. And the reason why I simply use a Python script to do this is because the data we use to show the sentiment is the Twitter data, which is a static data file, and it is stored in the CouchDB. If it is the data we periodically query from like Twitter API, we definitely need to run a Python service to periodically query this CouchDB endpoint to update the Twitter data and upload it to the Mapbox. But here, since we use a static file, we just use the Python script to do this. And now we have the GeoJSON file so that we can just upload it to the Mapbox. When you upload it, as you can see here, I can just select the Twitter data here, and after you select that, you're just gonna see here all of the data points here, and you can adjust the color with specified threshold. Here I define the threshold to negative 0.25, 0 and 0.25, corresponding to the color defined at the left hand side, so that you can see the data point rendered as in this way. And now we got the geomap. So how are we gonna embed it in the Grafana data visualization? What we've done is to just simply click the share here, and you can get a HTML code of website embed. And by copy this and paste it in this text. As you can see, it's a text type of data visualization, and you can just copy this HTML code line in this content box where we set the mode to HTML so that we can embed this geomap into our data visualization. And that's why we need to set as previously you see here, we need to set the GF panels disable sanitized HTML environment parameter to true, or we ain't gonna show, we can't display this geomap. So this is for the geomap. For the other bar plots or pie charts, take this as an example. As you can see here, we query the URL of the CouchDB API endpoint of a particular database. And so here we use Infinity as our data source. So Infinity is a plugin in Grafana. As you can see here, if you search for plugin, Infinity is just one of the plugins. We use it as a data source, so that we can use it to query data, and the type we define is JSON. Obviously, we want the JSON objects. And after query this data, we can receive the data we want. If I disable this transformation, you can see here, this is the raw data we query from the CouchDB API. And what the feature we really want is like here, we want a state, we want a tourism region, we want a number, which is all wrapped in this doc JSON object. So we need to do some transformation. We need to use this we need to use this extract field transformation to extract the embedded JSON objects in this doc JSON object. And we can then replace all fields with these extracted features. So it's gonna look in this way. And you can choose whichever feature you want to demonstrate on the stage. And then you can sort by the tourist node. So basically that's how we render this overnight tourism visitors in Australia. And similarly for this bar plot, we just query the similar endpoint, but we do further transformation by group by the tourism node, which is calculated through some other transformation. So for the pie charts, it's going to be a little bit different, but basically it's pretty similar. We just query another endpoint. We also extract the fields and choose the fields we want. We do some reduce row to calculate the count of each language. So that's why we have this count. And we just filter some weird data, which like 0. As you can see here, if we don't use this, there might be some weird data. And we just need to use some filter. And then we group by we use group by to calculate the count of each language. For the pie charts of the Twitter data, we use the view created in our CouchDB. So basically, we just query this endpoint, and we got this JSON object. Similarly, if you click table view, you can see here, and it's still rendering. I can see the loading bar here, because the $20 is big, as I said. Since Grafana will automatically automatically and periodically curate the COMP900 API, so even though it has already been rendered, since there is a curing rate, so as you can see here, it is curing again. So basically, this is how we implement this front end. Actually, we do have the data visualization of the built-in. Let me show you of the built-in geomap, but I've tried that, but the effect is not that good. Even though it can also show you the world map, but the best data points it can accept, it just like 2,000 to 3,000 is which is pretty small compared to the data points we have, which is 14,000 data points. So finally, we decided to use Mapbox and embed it in our Grafana data visualization. So basically, that's how we run. And the last thing I'm going to talk about is the instance that we run this Grafana Docker container. We just use a flavor of 1C4G similarly. And I didn't attach any volume since Grafana will not consume that much resource. Not like COMP900, which may store a lot of data. So here is the setup of the front-end instance. Yeah, so that's all for how we implement the front end. And thank you very much.